Welcome to the deep dive. So deep learning, it's really not just some lab concept anymore, is it?
Not at all. It's fundamentally changed the tech landscape.
Yeah, I mean, we see it everywhere. Self-driving cars, catching fraud, even automating jobs we thought only humans could do.
Absolutely. And, the big players, the ones really pushing innovation, they've all put deep learning right at the top of their priorities.
Right. But today, we're not just celebrating the tech wins, are we? We want to go a bit deeper.
That's the point.
We're looking at this huge shift it represents, moving away from those old rule-based systems.
The ones where humans had to write every single instruction.
Exactly. Towards something, well, newer, a different way of thinking about knowledge, maybe even intelligence itself. We're digging into the philosophical side of the code, you could say.
And that shift is crucial. It wasn't just an upgrade. It was a paradigm change. It really took off around 2006, maybe, with things like deep belief networks. And suddenly, machines could tackle these super complex tasks. Visual recognition, understanding language, even mastering games like Go.
All without needing humans to explicitly spell out every single rule beforehand.
Precisely. That reliance on hand-designed rules, that was the old way. Deep learning broke from that.
Okay, let's really unpack that difference,
Yes.
because it feels like it changes the definition of machine intelligence. We had symbolic AI first,
Right, the old guard, as you called it.
which was, if we're putting philosophical hats on,
Yeah.
top down, rationalist, grounded in logic, Aristotle and all that.
The human expert figured out the rules, coded them in, the machine just followed them deductively, everything explicit.
And deep learning.
It's kind of the opposite. Bottom up. Empirical. You don't start with the rules.
So what do you start with?
Data. Massive amounts of data. You expose the system and the structures, the rules, the patterns, they just sort of emerge automatically.
Okay, so if symbolic AI was like giving the computer this incredibly detailed instruction manual for everything,
Yeah, a massive checklist.
what's deep learning doing instead?
It's more like the machine is building its own internal map of the world layer by layer from experience. It's not just manipulating symbols it was given. Intelligence becomes about how these internal distributed representations are organized and interact. These representations it learned itself.
And, well, the results speak for themselves, right? The empirical evidence is pretty overwhelming.
Undeniably. We see deep learning outperforming the old methods in so many areas. Vision, hearing, driving cars.
Beating humans at complex games like Go and chess.
Even pushing into science, predicting how proteins fold, finding planets in radio signals, things that require finding subtle patterns in massive data.
So what's the core advantage? Why is it so much better at these things?
I think it comes down to what some call perceptual intelligence. Symbolic AI was brittle. It needed clean input, predictable situations.
Because it only knew the rules it was explicitly given.
Exactly. The real world is noisy, messy, always changing. Symbolic systems just couldn't handle that ambiguity.
But deep learning systems can.
They thrive on it to an extent. They can achieve goals in these complex, dynamic environments precisely because they learn and adapt using those internal distributed representations. They get context. It's less like following a script and more like having, well, intuition.
Okay, intuition. That's a big word. And that's where things get philosophically sticky.
Absolutely. Because now we're bumping up against centuries-old debates about knowledge, meaning, consciousness. The source material rightly points out that AI is just steeped in these ancient philosophical questions. Metaphysics, epistemology, ethics. It's all there.
So these two AI approaches, symbolic and connectionist, they map onto old philosophical divides.
Pretty neatly, yes. Symbolic AI is like the rationalist tradition. Top-down deductive knowledge comes from reason and innate structures.
And deep learning?
That's the empiricist camp. Bottom up. Knowledge comes purely from sensory experience, from the data, learning by sensing.
But if deep learning works so well, if it wins the games and drives the cars, doesn't that just settle the argument? Who
Yeah.
cares how it works if it gets the job done?
But that's the million-dollar question. Does performance equal understanding? Just because a system can identify a cat in a million photos, does it actually comprehend what a cat is? Does it have the concept? Or has it just become incredibly good at recognizing the statistical patterns associated with cat images?
So success isn't proof of real intelligence or meaning.
Not necessarily, and that's where the skeptics raise a crucial point. Are these internal states capturing genuine meaning and context, or just complex correlations in the data?
Which leads us straight into this thing called the symbol grounding problem. Can you break that down It sounds foundational.
It really is. It asks, how do systems like neural networks, which operate on patterns and statistics, subsymbolic level, ever connect those patterns to real meaning? How do symbols like cat or dog become meaningful to the system itself without an explicit structure telling it, this pattern means cat?
Right. If there are no built-in rules for concepts, for abstraction, how does it get beyond just pattern matching?
Critics argue it can't, not in the way humans do. So the debate becomes, is deep learning creating genuine intelligence? Or is it just an incredibly sophisticated simulation of intelligence, a powerful mimic?
Okay, simulation or not, these systems have some very real, practical problems we need to face, especially if we want to use them safely. Let's talk liabilities. First up, the black box.
Yes, this is a huge one. With symbolic AI, you could, at least in principle, look inside. You could see the rules. If A and B, then C. You could trace the logic.
Which gives you some level of trust or at least auditability.
Exactly. You could scrutinize the process. With deep learning, that's mostly gone. You have this incredible complex network, millions or billions of connections, weights adjusted through training.
But why it made a specific decision?
Often we simply don't know. The internal workings are opaque. It's literally a black box.
And that's not just a technical curiosity. It's a massive problem in high-stakes situations. Think about the justice system or healthcare or military decisions.
Absolutely. If an AI denies someone parole or recommends a risky medical procedure or identifies a target, and you can't ask why.
There's no explanation, no recourse, no way to check if the reasoning was sound or flawed.
Precisely. Accountability becomes incredibly difficult. It's like having a judge issue a verdict without explaining the legal reasoning.
Which connects directly to the second big problem, bias amplification.
Yes, because these systems learn from data, and the huge data sets we feed them, well, they reflect the world they came from, biases and all.
Historical biases, societal biases, they're baked into the data.
And deep learning models are exceptionally good at finding statistical patterns. If bias patterns exist in the data, the model will learn them. It learns to replicate the bias.
Or even amplify it, right? Because it's optimizing for statistical correlations, not for fairness.
Exactly. It finds the simplest, most efficient way to represent the patterns it sees. If that involves latching on to biased correlations, like associating certain demographics with higher risk based on historical data, it will do that.
So we see this in loan applications, hiring algorithms, facial recognition. The systems inherit and can even worsen existing societal biases.
And the black box nature makes it harder to even detect or fix that bias because we can't easily see how the system is weighting different factors. Philosopher Daniel Dennett made a related point. These networks optimize for efficiency, not for being explainable to humans.
So opaque decisions, potentially based on amplified biases, not a great combination.
Definitely not. It's a major ethical challenge.
Okay, let's hit the third weakness, which feels maybe less obvious, but potentially just as deep. Temporality, the issue of time.
Yeah, this is fascinating. Despite their power, current deep learning models seem to struggle with processing information over time in the way humans do. They lack a certain temporal depth.
What do you mean by temporal depth?
Well, human intelligence isn't just about reacting to the immediate instant. We integrate information over time. Our understanding of the present is deeply shaped by the past, by context that unfolds.
We build up a narrative, a context.
Yeah. Exactly. Think about understanding a conversation or a story. It requires holding information in mind, connecting current input to what came before. Our brains don't just take snapshots.
And the sources mention specific timings, right? Like, it takes us a fraction of a second to even process visual input, but maybe over 10 seconds to really show awareness for auditory info. That lag isn't slowness, it's processing time, context building.
Precisely. That delay suggests complex, context-dependent processing is happening. General intelligence seems to require this kind of intrinsic temporal flow.
And deep learning models, they struggle with this, even the ones designed for sequences like RNNs or transformers.
They've made progress, certainly. LSTMs, transformers, they handle sequences much better than earlier models. But often, they still operate more like sophisticated pattern matchers on sequences rather than systems building a deep, integrated understanding of context evolving over significant timescales. Many still feel like they're processing a series of slightly connected snapshots.
So, the challenge summary. We've got systems that are incredibly powerful at pattern recognition, but they're often opaque black boxes, prone to amplifying bias, and struggle with genuine temporal understanding and context. That sounds like a big roadblock on the path to AGI, artificial general intelligence.
It absolutely is. Just making the networks bigger or feeding them more data isn't likely to magically solve these fundamental issues of meaning, transparency, and temporal depth.
So how do we get past this? How do we build AI that doesn't just mimic intelligence but actually understands?
Right.
This leads us to the idea of Sophimatics.
Right. The thinking here is that we need to look beyond just the engineering and data. We need to reintegrate insights from other fields, particularly philosophy, to address these deeper conceptual gaps in deep learning.
We need to supplement the bottom-up empirical power of DL or something else.
Exactly. The proposal is to explicitly incorporate ideas from classical philosophy about the structure of mind and knowledge, concepts that maybe got pushed aside during the big neural network boom.
Which concepts specifically? The sources mentioned a few key figures.
Yeah, the big ones highlighted were Kant, Hegel, and Husserl.
Okay, big names. Can you give us the nutshell version of what they bring to the AI table?
Sure, so very briefly, Kant offers ideas about innate structures, the mind not being a blank slate, but having some built-in frameworks for organizing experience. Think prior knowledge for the AI.
Okay, so not learning everything from scratch.
Right. Then Hegel brings the idea of dialectics, understanding concepts through tension and opposition, how ideas evolve through interaction. This could help AI handle contradiction and dynamic change better.
And hostile.
Husserl brings intentionality, the idea that consciousness is always directed towards something, that mental states are about things, giving the AI a sense of focus, purpose, and the ability to ground symbols in context and intent.
So Sophimatics is the name for this potential next paradigm.
That's the proposed term, yes.
Yeah.
It's about combining the empirical power of connectionism, of deep learning, with these kinds of structural, intentional insights from philosophy, trying to get the best of both worlds.
Blending empiricism with, well, structure and meaning.
Structural intentionality, as the source puts it. The aim is to build more holistic cognitive architectures.
Meaning AI systems that don't just do things, but have some kind of internal grasp of why.
Exactly. Systems where meaning is more explicit, more grounded within the system itself. This could lead to AI that can actually give transparent accounts of its actions, that can reason about context more deeply, and adapt based on genuine understanding, not just statistical correlation.
Looking back then, deep learning has been this incredible lead forward. It showed us the power of perceptual intelligence, how machines can learn complex patterns from data and operate in messy environments.
Unquestionably, it advanced AI dramatically. But those philosophical hurdles, meaning reasoning, transparency, ethics, they remain the major barriers to achieving truly general, trustworthy intelligence. Operating as black boxes, they still lack genuine understanding.
So the big takeaway really seems to be that philosophy isn't just an academic sidebar here. It might actually be essential for the next leap in AI.
It seems increasingly necessary. If we want systems that are aligned with human values, systems we can trust, systems that are truly intelligent in a broader sense, we need to guide their development with these deeper insights about knowledge, meaning, and context. It's maybe the key to avoiding dystopian outcomes.
Right. We need AI that's not just capable, but also comprehensible and accountable.
And that brings us to the next stage of this exploration, which is digging deeper into Sophimatics itself, that integration of philosophy and AI mathematics. So we'll leave you with something to ponder until then.
A provocative thought to take away.
Considering those three philosophical pillars we mentioned, Kant's structures, Hegel's dialectics, Husserl's intentionality, which one do you think would be the most crucial first step? Which concept holds the most promise for helping an AI finally grasp intentional meaning, moving beyond just crunching the numbers?
Something to think about. We'll catch you next time for the next deep dive.